This video is brought to you by Sporlan, quality, integrity, and tradition.
We've got a kitchen AC that's not working properly today, so we're going to dive into this guy and see what's going on. While we were doing a preventative maintenance, service tech said that the unit wasn't coming on. They actually have a lot of units down. This unit right here is actually iced up. It's a split system for their kitchen, so I just disconnected the condensed unit so that way the air handler can continue to run. We'll dive into that in a little while, but we're gonna jump on this guy. So we're gonna start by just doing the most common things: belts, filters, check those, and we'll open up the electrical section and troubleshoot further there. Like I had said, I had a service tech doing a maintenance, so the filters are brand new, they look great. Now this particular building has an energy management system or a building automation system, and some of the thermostats, or whatever you want to call them, for the automation system don't work. So I have several units that I've quoted many times, but we had to add a thermostat to get them by, and then the customer just hasn't upgraded the EMS system or had it repaired or anything. So we have to verify what's actually controlling the unit. So in this case, this one has a thermostat that's just temporarily, again, this was like 2 years ago, dropped down into the duct, and the customer just hasn't done anything to fix it since. Belt looks fine, like it should. Everything looks cool. The blower assembly is a little bit dirty. To clarify though, the customers on these things, when they have us do a preventative maintenance, all that they want us to do is change belts, change filters, rinse off the condenser. Cleaning evaporators isn't part of it. Splitting condensers isn't part of it. Pulling blower assemblies, like, all we do is make recommendations to the customer, and then they approve repairs. But so the PM service, you know, every PM might be different depending on the customer's wants and needs. You know, most of the time dealing with restaurants, they just want you to come in, clean, and then let them know if there's a problem, or if it needs extensive cleaning, then, you know, you have them create a service ticket and you do it from there. The unit is powered on. We're gonna check to make sure we have three-phase power coming to this unit. Yes. And then yes. And then yes. So we have proper three-phase power coming to it. Now let's go over to the thermostat control voltage. Okay, R and C, 24 volts. Now C and Y1, nothing. And then C and G, and the indoor fan is running, so we're good on that. We need to go over to that thermostat on the other side. Like I said, this one has that thermostat. We need to see if we have a call for cooling from the thermostat. So I had some incorrect information. It actually wasn't this unit that was problematic. It's their other kitchen unit on the other side over there, right there. So this guy's running. It's working like it should be. We're gonna put this one back together and jump over to the other unit. All right, we've got a kitchen AC that is not working, obviously. And we gotta figure out what's going on. So we're gonna open this guy up, start with the basics, electrical section, filters, belts, and then see what we can get into here. All right, just doing a visual. Indoor blowers, okay, it's got grease in it, obviously, which happens in these kitchens. Belt's tight. It's a little dirty in here, but I don't see anything jumping out at me. We're just doing a visual. Okay, so we need to test to see if we have three-phase coming into the unit. 1 to 2, 210. 2 to 3, 210. And then 1 to 3, 212. So voltage is right as far as main power coming in. So we're gonna go ahead and go over here to these thermostat wires now and see if we have a call for cooling. Okay, R to C, we have 24 volts, that's correct. Y1 to C, we have nothing. And then G to C, we need to find fan. G to C, we have nothing. So we do not have a call for cooling on this guy. We need to figure out down at the thermostat if it's actually calling or not. So I'm gonna take a trip down there. So this is our thermostat right here. It's part of an automation system, and we have a power light, but we have no OCC. I'm gonna bet, I'm waiting for EMS to call me back right now, but I'm gonna bet that we have another thermostat that's gone bad. So we've got this one that's bypassed, this one that's bypassed, this one's that's bypassed, and the customer just hasn't. Apparently they don't want to use these anymore and they want to upgrade to a whole new system, but it's like a big process, so I don't know. I just pass on the information, but I'm waiting for them to call me back, but I'm going to be pretty confident we're going to have an issue with this guy. I'm sure it's got no communication. All right, temporarily, in air quotes, I installed the thermostat in the return airstream right here. It's set and programmed to turn on and off at normal times. It's just zip tied on here temporarily. Again, I don't get too involved in the politics with these energy management systems and stuff, because the customer purchases their own replacement thermostats and stuff when it comes to the EMS system. So bottom line, I got to get the system operational, and they're okay with me putting in a thermostat. Now, the next question I get when I do this, why the heck did I use such an expensive thermostat? Okay, that's all that I stock in my truck, and I'm out in the boonies right now, out in the middle of, you know, where it's going to take me 45 minutes, if not longer, to get to a supply house. So I'm trying to save the customer money. That's what I keep in my truck. I keep one thermostat in my truck, in all my trucks. We all keep this same commercial Honeywell thermostat, even though it says home on it. That's just because of the whole Residio Honeywell thing. If you guys don't know, Honeywell sold their thermostat, their residential and light commercial thermostat division to Residio. It's like a whole thing, but they still brand them with the Honeywell home name. It's kind of silly on these commercial stats. But anyways, regardless, that's the thermostat that I use. That's what I keep in all my trucks. That's what they get, because it's going to cost them more for me to go drive to find the right thermostat to put it in there and that kind of stuff. Okay, so we put that in there. It'll last as long as the customer needs it to. Like I mentioned, I have a thermostat here that's been in there for over 2 years like this, so it is what it is, right? All right, we're going to put this back together and finish troubleshooting the unit, make sure everything else on it works properly. All right, our thermostat is calling, or at least on the thermostat it says that it's in cooling mode. So we're going to check from Y1 to C, and we have a call for cooling, 26 volts, okay? You guys can't see it, but the economizer module is not holding out the compressor. It scrolls across and it has a marquee. It's hard to see, but it says that it's not the problem. So next thing we're going to do is check our pressure controls, okay? So we have a high pressure and a low pressure right here. So if we go across high pressure, we have 0 volts, which is a good sign. That means the control is not open. And then we go across the low pressure, and we have 26 volts on the low pressure control, meaning that the switch is open. All right, it's a pressure switch. And if we look at our pressures in the system, it's a 410A system. We have 86 PSI equalized out. When I did put the service gauges on the system, I thought that looked low for sure, but I also saw some oil in here, and on the compressor section, there's a little remnants of oil too. So we're gonna have to get in and try to find a refrigerant leak. This guy's definitely low on charge. So this is all factory, and it's weird. If you look at that liquid line filter dryer, coming out the filter dryer, the liquid line comes up right here and then goes into a flare nut. That is not a piston. That's just a flare nut that's then going into, it's all actuator metering devices, fixed orifice. There's little dimples in the lines right there. That's bizarre. So we need to get the leak detector out and see if we can find the potential source. I definitely see something down here on the bottom of the dryer. It's a little oily. So we'll get the leak detector out and try to pinpoint this guy. Make life easy, I popped the top off the unit. It doesn't take much. And we're gonna do a quick leak search. You can kind of see some more oil when we do this, because the whole bottom of this unit has a little bit of oil right on the bottom of the filter dryer, right in here. But I'm not seeing anything. Just kind of following the oil. And there it is right there. Leak detector's going crazy. There's a rub spot right there where the two lines rub together. We'll get some soap bubbles on it. Get some big blue micro leak detector. I mean, we already know it's there. This is just for to be able to see a little bit better. And it's bubbling like crazy right there. So we got to get in here, repair this leak, and change the liquid line filter dryer. All right, it seems like I brought my entire van up onto the roof. We're gonna get recovering on this guy. We're gonna make a few repairs. We're gonna, if all goes well, we're gonna eliminate these high flow Schrader things and put in normal Schraders. Yeah, so we're gonna get the recovery process started, and then we'll start fixing it. Now this guy barely has any gas left in it, but we still gotta do our part and recover the gas. So just working on that right now, getting what's out of there. We're starting to kind of sand up a little bit, get things ready. I sent someone to go get a dryer, and yeah, we're gonna try to clean this guy up a bit. All right, I've got nitrogen flowing through the system. I went ahead and unsweat this high flow Schrader core fitting. I pulled off the mechanical part and took that off, because we're gonna cut this out of the picture and I wanted to be able to cut as close as possible without hitting the brass. It would make it so the cut was longer. So I have a special T we're gonna put there. So we're gonna cut it as close to the braze joints as possible, cut out a small section, then we'll put a T there with an access fitting. I stand corrected. This is a piston. But it's weird though, because it's really small. But you can still see, I'll put it back in there, but you can still see the dimples from the fixed orifice metering devices in there. So I'm curious what they're doing here. That's very interesting, huh? But yeah, that is a piston, but it's not removable. Huh, it's really bizarre. Kind of doing this in stages. So we got that piece put back in there. This is where our leak was at. This little guy right here, that was it, just rubbing against the line. So probably gonna redo some stuff here. Okay, so it can't always be perfect. The nitrogen's not flowing through these braze joints right now. Oop, now we're melting stuff. Oop. Having a hard time right now. There we go. So you can't always be perfect. Nitrogen's not flowing through this right now, but it'll be okay. No, that's stuff. A real ugly spot on that. Not perfect, it's ugly, but it works. So I'm not perfect, kind of looks a little bit ugly, but it's functional. It's not gonna hurt anything. We don't get a lot of moisture here, so we don't need to worry about this. I mean, you know, it is what it is. I did this part out because it's gonna be hard. I didn't want to have to climb too crazy in the unit. So, well, my phone crapped out, didn't like the heat. But we only had like 3 more braze joints. So we got this guy soldered in, this guy, the dryer's in. We got to find a way to secure the dryer. I was going to try to use the existing panduit strap, and I got new panduits, but they're too wide for it, so it's not going to work. But yeah, we just need to strap everything in and get the evacuation running on this guy, and then hope that, I need to put some nylog on this guy and tighten down that piston. I'm still tripping out on what that is, because the typical fixed orifice metering device has a double orifice already. So I wonder if maybe they reused like an R22 evaporator and added a second restrictor. I don't know. I don't understand it. So we did a pressure test. It's been running for about 5 minutes. We've gone up 0.2 PSI. It makes sense because we're sitting out in the sun.
There is a big misconception that nitrogen does not change pressure when the temperature changes, and that is completely false. You can actually see it right here. Because I pulled the top off the unit, the sun is now hitting the condenser and the evaporator. It's raising the system temperature via just the sun hitting the surfaces of the coil, and my system went up 0.2 PSI when it just had nitrogen in it. Now, to be fair, we also very most likely have some refrigerant still boiling out of the oil in the compressor, okay? Because we were purging with nitrogen the whole time, but you're still going to get off-gassing from the oil, okay? But the most important thing to understand is nitrogen does change pressure with temperature, okay? As the temperature drops, the nitrogen pressure will drop, and as the temperature rises, the nitrogen pressure will rise, okay? So it does not stay the same all the time. I'm not scared by this. We're going to go ahead and stop the pressure test and get the evacuation running. We're kind of all set up for that. So we'll get it running, and then we'll start putting the top back on the unit. Remember, this system never came in contact with atmosphere, really. We were pushing nitrogen through it the whole time. It never ran out of refrigerant. So really, we're pulling the nitrogen out and the refrigerant out. We're not really pulling any moisture or air out, really, because it really didn't have an opportunity. But yeah, it's coming down. 880 right now, so give it some time. All right, so pulled an evacuation, and then
left the core tools closed. I guess I should have caught it on film, but it left the core tools closed, put the manifold hoses on there, and then evacuated the manifold down below what the micron level of the system was. That way we had a clean system. We're charging it up now. We're at 12 pounds right now, and I think it takes 14.5 pounds if I remember right. Let's go over here. Just about, so it's 14.5 pounds. So we're just about there. Let's see if it'll take any more. I don't know if it will. And we'll probably have to turn it on and meter in the rest. We're looking pretty good. We're right on the money on the pressures. Superheat's right about where it should be. What's the target? The target's about 5 degrees. We're running 4.6. This is just weighed in factory charge. I'll tell you the airflow is probably jacked up on this unit. I know the ductwork on almost every one of these is kind of low, but temp split's kind of high. But it's also pulling a little bit of outside air, and the ductwork's jacked up. So I think this guy's doing everything that it can. I do want to show you guys something though about the pressure drop across the condenser. There's been a lot of talk about whether or not there is pressure drop across the condenser. We're running about 377 PSI liquid line pressure, and we're running 393 discharge line pressure. And I've got liquid line port back here, discharge line port up there.
So you can't just stop at the first thing. When we found the bad thermostat and we got it changed out, we don't just assume that's it. We finish diagnosing, going through the rest of the unit, and then I found a refrigerant leak, okay? I did make some system modifications, adding a liquid line port. I like that because then you can get a true subcooling, and I also was able to get it on video, the actual pressure drop across the condenser. I know there's some people out there that think that there's not a pressure drop, right? But there is. It varies from manufacturer to manufacturer in my experience, and it also depends on the SEER rating of the unit. The higher the SEER rating, in my experience, the bigger the pressure drop. But anyways, but it does exist, and it's kind of it's really hard to use a rule of thumb to guesstimate what the pressure drop should be, because like I said, every manufacturer beats to the tune of their own drum when it comes to how they design their equipment. Okay. So really nothing too complicated on this one. We did make, like there was a mistake when I was brazing in the liquid line filter dryer. It opened up a hole. It's not the end of the world. We don't have to have the picture perfect Instagram install. Of course I strive to make my stuff look nice, but I'm also practical. Like, I'm not going to rebend that whole piece just because I flared out a hole. Like, boom, solve it. I was a little intrigued by that extra piston. That's still kind of tripping me out. I'm curious, because I've opened up these evaporators before, and they have a fixed orifice metering device. I kind of showed where the little pinch points are on the distributor line or whatever coming out of the liquid header, going into the evaporator. And I've autopsied those before, and there's actually 2 restrictors in there, or 2 pistons normally. But on this one, I'm wondering if they have 1 piston outside and 1 piston right there. I don't understand what they're doing with that extra restrictor. Who knows, though? Again, these manufacturers beat to the tune of their own drum. I'm surprised, with a 14 SEER unit, that this thing has a fixed orifice metering device and not an expansion valve. But, who knows? We run into interesting stuff out in the field. Given the opportunity, I pulled that thing out because I was curious what it was. Instead of just saying, I wonder why that's there. It really wasn't that big of a deal for me to unsweat it real quick and just kind of inspect it and be like, oh, it is a piston, Of course, I'm not going to do that if, we're not doing repair work on it. But anyways, you guys get the gist, okay? I really appreciate you guys making it to the end of the video. It's the support that I get from you guys is amazing. If you haven't already, please check out my website, hvacrvideos.com. Merchandise available on there. You can help support the channel. There's links in the show notes for all the other different methods that you guys can support the channel. This is my last video of 2021. I'm recording this right now on 12/29/21. So happy new year to all you guys. Hopefully, you guys have a great 2022, right? I'll see you guys then on the other side. We got all kinds of cool plans for 2022, all kinds of different places I'm going to be going. I will be at the AHR Expo in Las Vegas here in the beginning of 2022, and I will also be teaching, or I'm sorry, presenting at the HVACR training symposium, the HVAC school training symposium at the, what is it, the middle of February. I'm 99.9% sure I'm going to be there in person, but there's a very small chance that I will be doing a virtual presentation, but more than likely I will be there in person. So if you guys, any of you are going to either of those events, definitely pay attention to my social media, and I'll have times when everybody can hang out and do all that good stuff. Okay, so I really appreciate you guys, and again, Happy New Year, and we will catch you on the next one. Okay.